Hey there, welcome to 7a, Chapter 7. We are moving on from quadratics, and now we are going to dive into Chapter 7 and 8, which are arguably the last units of grade 10 math. Trigonometry. So we're just studying triangles for the next two chapters. Properties of similar triangles, Chapter 7.1. Congruent. Okay, let's start with congruent. Congruent just simply means the two triangles are exactly the same. Okay? Exactly the same. So, let's call this triangle A, B, C, and let's call this triangle D, E, F. Okay? So, concurrency statement. So, in order for two triangles to be congruent, everything needs to be the same, which means AC, we can see, are the same as DF. Okay? AC is exactly the same as DF. AB is exactly the same as EF. And BC is exactly the same as DE. Okay? Now we can also see that the angles are exactly the same. So angle ABC, angle ABC. So when writing angles, that middle corner represents the angle itself. So in this case, we're talking about angle B, so we write it angle ABC. Is the same as angle DEF. DEF. Okay? And then angle BAC, angle BAC is the same as angle. So BAC, which means I'm going from the 85, BAC would be the same as EFD, angle EFD, and not DEF. Minor detail, because if I put DFE, that means I'm going from 35 to 85. But here I went from angle BAC, that means I'm going from the 85 to the 35. Okay? And then last but not least, angle FDE. So angle, or I guess I should have, angle FDE. So angle FDE. So it's the 35 degree angle, but we're going from the 60 to the 85. So 60 to the 85, which means it's ACB, angle ACB. So therefore, triangle ABC is congruent to angle, now we need to correspond the right letters now, ABC. So A is the 60 degree angle to the 85. So 60 degrees to the 85, so triangle F. So what do I mean by that? ABC, meaning I'm going from 60 to 85. 60 to 85, so FED, angle, triangle FED. Okay? They're congruent. Now, it would be easy if we were just studying triangles that were exactly the same. But instead, we're going to look at similar triangles. Okay, and there will be three conditions for triangles to be similar. Let's take a look at this one. Let's compare sides for a second. Okay, so if I look at side AC and HF, obviously the numbers aren't the same. But let's see if there's a pattern or similarity between the ratios. So if I look at the ratio of side, okay, I'm going to go AC divided by HF. That will give me 84 divided by 14. And that gives me 84 divided by 14 will give me 6. Okay, so let's take a side 1. Let's take a look at another side. Let's take a look at side 2. Maybe I'll look at 72, maybe compare that with the 12. So if I look at AB over HG, that will be 72 divided by 12. That also equals to 6. And last but not least, let's look at the bottom one here. So if I go side 3, and I'm going to go from CB, so CB with FG, that's 48 divided by 8, which also equals 6. So here's one of our similarity statements. If the ratio of the three sides are the same, the two triangles are similar. So if the ratios of the three sides are the same, the two triangles are similar. The triangles are similar. Okay, and how do I write that? Well, I would say since, so this looks like a therefore sign, but if it's upside down it means since, or because of side, 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 because the ratios are the same, triangle ABC, so A, B, C, then this little sign means similar, similar to ABC. So I went from blue to pink, so HGF is similar to triangle HGF. Okay? Let's take a look at another situation. Angles. Now thinking back to grade 9, if we look at these two angles, okay, opposite angles are the same. So let's use theta for an angle. Well, I guess you guys might be new to, so this just means theta. And what does theta mean? That just like an x represents an unknown number, this just means it's an unknown angle. That's all. Okay? So in this case, we know that angle MVL is the same as TVU, angle TVU. Okay, so here's an angle that's the same. Now let's look at the ratio of the two sides that are given. So if I wanted to compare T and V, so side 1, so TV compared to MV, that will equal to 49 divided by 14, which will give me 3.5. Let's check the other side. Let's check UV, so side 2, UV over LV, which will give me 28 divided by 8. And what would that give me? 3.5 as well. Okay. So what do we have here? We have angle, side, side. Maybe it was a poor choice in how I approached that question, but typically it's SAS, side, angle, side. Why is it side, angle, side? Why is it side, angle, side? Because it's going to be the angle that's contained by the two sides. Okay, notice how the red and the blue both contain the angle that are the same in both triangles. Okay, and if you think about this logically, if you were to try to create a triangle, so grab two toothpicks, okay, that have the same factors. So for example, grab one toothpick and have the other toothpick that's maybe 4 times bigger, or 3.5 times bigger, or 6 times bigger, and grab another toothpick over here of any length, and just make sure the other one is the same ratio, so 4, 3, whatever, and have these angles the same. That will force the other side to have the same ratio as well. Yeah, so it's not given to us, but we assume it is. So how do I write this statement in this case? Since side, angle, side is the same, or the ratios are the same and this angle is the same, then we also know that triangle MVL is similar to triangle T, so MVL, TVU, TVU. Okay? So this is just condition number 2. Now this also means that because of the three ratios being the same, in the first scenario where the three sides ratios are the same, I can assume that this angle will be the same as this angle, this angle will be the same as this angle will be the same as this angle. Similarly, looking down here, because I know that these ratios, the ratio of these two sides are the same, ratio of these two sides are the same, these angles are the same, I can also assume that the ratio of these two sides will be the same, even though no numbers are there, which satisfies my first condition. And I can also assume that this angle will be the same as this angle will be the same as this angle. Okay? And the last condition is the easiest, and that is, we can see that angle T, and you can tell that they're the same just by the way that's written. Okay, so angle VTU is the same as angle, so VTU will be the same as angle LJK, angle LJK, and angle VUT is the same as angle LKJ, angle LKJ. So in this case, all we need to do is verify. So since, or because of angle, triangle, VUT will be similar to triangle LKJ. Okay? Now once again, because we know those two angles are the same, and if you think about it, that means it's 180 minus these two, because three angles in a triangle add up to 180, which will give you this angle, which will make these two angles the same, and since they are similar, we can assume that the ratio of the sides will all be the same as well. Okay? So a lot of these practice questions are simply for you to state whether they're similar or not, just by seeing if they fall into one of these three categories, whether it's side, angle, or angle. Okay, awesome. All right, see you guys next lesson.